So in this video, we're going to look at trigonometry and finding missing angles. Now, how do you know that you need to use trigonometry? Well, you know because you're asked to find an angle. Pythagoras' theorem helps you find missing sides when you've got two sides, but it will not help you find missing angles. So what do you need to know for trigonometry? Well, firstly, you need to know the SOHCAHTOA triangles, and you need to know them inside out. So you've got SO, and I always put the theta there to remind me that I always write an angle next to sine. So that's SO, Ka, and TOA. And I always write my thetas there to say that I always write an angle. The second thing you need to know for trigonometry is how to label a right angle triangle correctly. The side opposite the right angle is the hypotenuse. You label it with H. The side opposite the missing angle is called the side opposite the angle. The remaining side is the adjacent. Adjacent means next to, it's next to that angle that we're trying to find. So let's look at our triangles and label them. Step 1, let's label. Angle opposite the hypotenuse, opposite the right angle is the hypotenuse. The angle opposite, the sides opposite the right angle is the hypotenuse. The side opposite the missing angle x is the opposite. And the final side is the adjacent. Now, which two sides do we need? Well, of course we need the sides with measurements on. What are we going to do with the hypotenuse? With that side, it doesn't have any measurements, so I don't actually need this one. I need the sides with the two measurements, so O and A. Well, which of the triangles has O and A? O and A is in TOA. So I'm going to write this down. TOA. Now, because we're finding angles, I already have the opposite, I already have the adjacent. I can't cover them up. There's no point trying to cover them up. I already have them. I'm not trying to find the opposite. I'm not trying to find the adjacent. When we're finding angle, what you do hide is the actual ratio. The T, the sine, the tan, the cos. So the T, the S, and the C. You cover them, and then you read from the top, and it says O divided by A. But there's an extra step. If you're trying to find angle X, you have to do tan minus 1. That is the opposite of tan. You're trying to reverse tan to find the angle. Tan minus 1, and then you open your bracket and you do opposite divided by adjacent. So that means you're going to write in your workings tan minus 1, 3, which is opposite, divided by 6. Now, how do we get tan minus 1 on a calculator? Well, we get tan minus 1 on a calculator by doing shift, so pressing shift, then tan, and you can see it gives you tan minus 1, and then 3 divided by 6, and you close the brackets and you press equals, and this gives you the angle. Now, the angle, they usually ask you for 1 decimal place, so you start counting after the decimal. It's not significant figures where we start counting from the 2, from the very first number that's bigger than 0. We start counting from the decimal. So this is the first decimal place. I therefore have to look at the 6. The 6 tells me to round the 5 up, so my angle is 26.6 degrees. X, the angle, is 26.6 degrees. Now, for my second triangle, I'm doing the same. The angle opposite, the side opposite the right angle is the hypotenuse. The side opposite the missing angle is the opposite. I don't actually need to say that this is the adjacent because I don't need it. I've already labeled the two sides with measurements. So what I want is a ratio triangle that has H and O. So H and O is the sine triangle, the SO. So I'm going to remove these and I'm going to put SO. And I'm going to get my little hand, and because I'm trying to find an angle, it is the ratio itself that I cover. So I cover the S and I start reading from the top. It says O divided by H. And because I'm finding an angle, I have to do that extra step, which is sine minus 1, and then O, which is 4, divided by H, which is 15. And again, you get your calculator and you press Shift, sine, 4 divided by 15, close brackets, equals, and again, they'll want the angle to 1 decimal place. So I start counting from 4, and so 4 is my first decimal, the first number after the decimal. So I look at the 6. 6 tells me to round the 4 up, so I round the 4 up to 5, and my final answer is 15.5 degrees, because it's an angle. And with my final triangle, I'm doing the same. The side opposite the right angle is the hypotenuse. The side opposite the angle is the opposite. And the final side is the adjacent. So which two sides do I want? Well, I want H and I want A, because these are the two sides that I have. So H and A, that's K. So I'm going to write this down. And if I get my trusty little hand, I have to cover the C, the cos, because it's an angle I'm finding. I already have A and I already have H. I don't need to cover them. I already have them. So X, the angle X, is cos minus 1. I have to do that extra step for angles. I open the brackets and I read from the top, and it says A divided by H. So A is 8 divided by 10. And again, I get my calculator and I press Shift, cos, and it's 8 divided by 10, close brackets, equals. And again, they want it to 1 decimal place, so I start counting from the 8. 8 is my first number after the decimal. I need to look at the 6 to tell me what to do with this 8, and 6 tells me to round the 8 up to 9. So it's 36.9 degrees is the answer. 36.9 degrees is the answer.